Sass Class with Amanda. Hey. In this video, we're going to be working through an example using stem plots so that we can understand them a bit better. So here we have randomly sampled 15 people from an international airport and determined their hourly wage, probably by walking up to them and saying, hey, how much do you make an hour? And also, let's assume that we ask them in the same dollar amount, so let's assume that we asked them how much they made in US dollars per hour, and we have 15 data points, okay, $7.25 an hour, $8.05 an hour, $15.15 an hour, etc. I tried not to go below, I guess, customer service minimum wage in North Carolina, and the rest of the values I sort of made up. Alright, so let's create a stem plot. But before we create a stem plot, we have to figure out what is our stem going to represent and what will our leaf represent. Okay, so remember we have these two portions, stem and leaf. And in one of the other videos, we had ones digit, tens digit, hundreds digit, etc. So notice none of these dollar amounts are in hundreds, so we don't have to worry about that, but we do have tens and we do have ones, but we also have tenths and hundredths. So we have lots of digits to choose from, lots of positions to choose from. So what do we do with decimal numbers? Well, I would recommend to use this as the decimal, and so our leaf can be something on the left-hand side of the right-hand side of the decimal, and stem can be something on the left-hand side. So we need to actually round these values in some way because the leaf needs to be the very last digit. Okay, so we only want one digit to the right of our decimal. So let's round this to 730, and round this to 810, and round this to 15.2. This stays 30.0. This will stay, oh, I guess not stay anything, that's 7.7, 7.3, 9.8, 10, 10, 7.5, 8.1, 23.0, 50.1. So some of these values stay the same, which is nice. 8.4 and again 7.3. Alright, so alright, so what do we have here? Now we have 7, 8, 9, 10, and you have also 15, etc. So, but we're going up in value, right? So 10, the highest dollar amount we have here is 50. So I'm not going to write all these values, but we do have 7, 8, 9, what is it, 15. So imagine dots. 15, 23, 30, 43, and then ... 50. Alright, and we already said that the leaf is going to be the very last digit, so the one digit to the right, and so what do we have for that digit? Well, under 7 we have 3, 3, 3, 5, 7. Under 8 we have 1, 1, 4. Under 9 we have 8. 10 has a 0, and then at 15 we have a 2, 0, 0, 0, 1. And I guess it's also acceptable for you not to include these spaces, but I like to include them because it makes it very clear to me that there are deviations in our data. All right, so we created our stem plot. Why are we using a stem plot is maybe what this question is asking. I think that if we have a small data set of 15 individuals, I think it's okay for us to use a stem plot because it's not very large, and it gives us a description of what those individual values are going to look like in this graph. All right, so let's describe the shape, center, and spread. So notice that our shape is left skewed. Okay, so this dinosaur has a really long tail, which is cool. Shape. Right skewed actually. Don't forget to turn your head in order to see the direction of the tail. Alright, so our center. So what is our center? Well, you just want to count the data after they've been put in order. So it's 15. So what is mid 15? It's approximately 7.5, right? So 1, 2, 3, 4, 5, 6, 7 is 7.5 is between 8.10 and 8.40. Alright, and now our spread is the minimum, which is 7.30 to 50.10. Alright, so are there deviations? Oh yeah, there's so many deviations, right? We have one here, another one here, another one here, another one here, right? So it's more common for, in this data set anyway, for the person to have run into people making minimum wage in various ways than for them to run into people who are making much more money. Okay, so deviations. So many. The last part of this question asks what would the histogram look like. I'm going to leave that for you guys to explore. I think that the stem plot is slightly more difficult to talk about just because we have this decimal to deal with.
My name is Llama, and I'm here to teach you stats, skilling you up with them cold hard facts. We live in a world of technology. They're collecting information on your humanity. Social networks, gaming, and in-home software.
Hello, Alexa.
Statistics helps us be more aware. Haters gonna hate my spicy lyrics. Why you gotta be so mean? Pulling me towards your extreme moods, but the median never fails to center me. 50 to my left, 50 to my right. Got these correlation and regression tools, forget them fools. My name is Llama, and I'm here to teach you stats, skilling you up with them cold hard facts. My name is Llama, and I'm here to teach you stats, skilling you up with them cold hard facts. The mean of the means is the mean. The mean of the means is the mean. The mean of the means is the mean is the mean of the means is the mean is the mean. Be careful not to fall in love. Statistical seduction from above. Your shape so beautifully symmetric to the eye with a single peak so high. I hypothesize and can testify that your p-value is the smallest I've seen. Mix that with a large power and I reach ecstasy. Your residuals defy the rest. A small scale randomized pattern tells me you are the best fit. My name is Llama, and I'm here to teach you stats, skilling you up with the cold hard facts. My confidence is so high, 95%. My margin of error so nil, 110. Can you feel me? Can you feel me? I estimate your population parameter based on only one sampling. Oh, haven't the frequentists told you about me? We live in a world of data, attempting to understand life by statistical strife. The implicit bias of cops, success rate of them jocks, medical advances, and AI romances. Statistics.